There are various reaction time and response time questions. You need to know firstly the three definitions for reaction time, movement time and response time. Reaction time is basically the time it takes you to make a decision. So it all happens in the brain. It's the information processing part of the decision. So an actual definition would be the time between the stimulus and the start of the movement. In other words, as soon as you start to move, that's reaction time over. So it's the time it takes you to take in all the information, use your perception, selective attention, etc., make the decision with your memory stores and send the motor program down to the muscles. As soon as that muscle receives the motor program and starts to move, that's reaction time over. So that would then be movement time. So movement time is the time between the start and the end of the movement. So in terms of the sprint start here, you can see that as Bolt starts to move there, and that's the start of the movement time, and the end of the movement would be the end of movement time. Those two things put together gives us response time. So response time, as we can see at the bottom, is reaction time plus movement time. So that equals response time. So this equation is worth remembering about response time, that it's made up of those two things. So again, we would just put those two definitions together, that it's the time between the stimulus and the end of the movement. So the whole thing put together. Lots of factors that affect your response time. These could be things you might not be able to do anything around, like your age. I think it's obvious that as we get older we get slower at responding. Gender, it's shown that males can respond quicker. Experience or anticipation, so this is key in lots of things like game sports, team sports, where you can experience of the situation. If you have better schema and more motor programs developed, then you know the situation, you can recognise patterns more quickly, pick those out and make a decision a lot quicker. The intensity of the stimulus as well, so if it's loud or bright or large, for example, it will be easier to pick out and therefore respond quicker. Hicks law, which we'll cover later, but if there are more choices, obviously response time will be slower. With the less choices, the quicker reaction time will be. Selective attention, so if you are picking out the right cues, you will respond faster, and your levels of fitness may impact on particularly the movement time part of response time, and therefore affect the overall response time. Your arousal level, so normally with a higher level of arousal we would respond quicker, but this could also be whether you're at an optimal level for yourself or within your sport. And lastly, the PRP, so the psychological refractory period, that can also impact on response time if there are more than one stimulus thrown in very quickly, one after the other. That would make us respond slower. Two types of reaction time that we need to know the difference and how they would affect. So firstly, simple reaction time is fairly straightforward. Here there is only one stimulus and one response. So example will be a start of a race, so the swimming buzzer goes off and the swimmers have their one response. So they are listening carefully for that one stimulus. They already know the predetermined one response, which is to dive in. Choice reaction time would happen more in game sports. So we can see the netballer here might have lots of things going on in terms of defenders, her own attackers trying to get free, so she has lots of options to pick from, lots of passes potentially to do. She may be deciding to shoot on this occasion as well, so does she pass or does she shoot? And that all happens obviously very quickly. So here there are lots of stimuli around in the environment, and she also has more than one response available. This is linked to Hicks' law, so we can see that Hicks' law suggests that with more choices available, this means a longer reaction time. So you can see that the number of choices comes along the bottom here, and reaction time goes up the side. So we can see with more choices, reaction time starts to increase. The psychological refractory period comes about when we get two stimuli very close after each other. So stimulus 1 on this occasion, this could be that an attacking player decides to move to their left, and then very quickly that attacking player also then decides to move to their right, so we get stimulus 2. So these two things are thrown in very quickly, one after the other. This can impact on reaction time. Basically, the reaction to the first stimulus would be a normal reaction time. So you can see here, this is a normal reaction time to the first stimulus. However, the second stimulus comes in, as we can see, in between that first reaction. So what happens is it takes us up until this point where we've responded to that first reaction to be able to start to deal with this second one. So this little bit here is wasted time, and this is called the PRP here. So only now here can we start to react, and so again we have our normal reaction time, but as you can see at the bottom here, the overall reaction time of that second stimulus takes us longer. Questions on the exam tend to ask this around a ball hitting the net. So a badminton player, for example, hits the ball and the shuttle, and so that's our stimulus 1, and then the shuttle hits the net, which is stimulus 2, and takes a deflection. So what we're saying here on this occasion is the player defending against that shot would take longer to respond to that second stimulus of it hitting the net, and may not even get to that shot, for example. So if you're asked a question around psychological refractory period, in order to explain this concept, you would need to talk about the following. So it's explained by what we call a single channel hypothesis. Basically, this just means that we just have nerves travel along one path. Okay, so only one item can travel along that path at a time. So if we try to get a second one to come along here, it's got to wait until the first one, which is the blue line, until that one's cleared. So once that one's gone through, the second one can then travel through on the same line, on the same nerve. So this is called the single channel hypothesis. But what we're saying is this second one then takes longer. So in terms of that, we also sometimes call that the bottleneck effect, because we're getting more than one stimulus queuing up as it would at a bottleneck. So the first stimulus that we have, as we discussed on the previous graph, the first stimulus must be cleared before we can deal with the second one. So this is advantageous for attacking players who can throw fakes and dummies. Even research shows that even if the defender knows it's a fake, they still have to process it, and it still takes them longer to deal with it in terms of their second response. So that defender or the badminton player can only deal with one stimulus at a time, also, and that all ends up with a delay, and that's a key word, the delay in the response to the second stimulus. So how can the coach improve a performer's response time? We can use lots of answers that we used in our factors affecting response time, because obviously if they affect it, we can use it to improve. Obviously things like age and gender we couldn't do on this occasion, but we have lots of the other types of answers that we had there. So we have selective attention, make sure that we are paying attention to the appropriate cues, picking out the right cues. Relevant practice, make sure that we say relevant on this occasion, not just practice for response time. It needs to be relevant practice in terms of picking out the right decisions with the right cues and making decisions. So again, it would be if we're a games player, we need to be making those types of decisions, not just doing some fixed practice where you wouldn't have to make a decision. Getting to your optimal level of arousal. So arousal can affect your response time, so make sure that we're there, make sure that we're psyched up enough or relaxed enough in order to make those right decisions. Anticipation, two types. There's temporal anticipation, which is when, so that's anticipating when it's going to happen, so anticipating when the tennis serve is going to arrive. Spatial is what, so in terms of the tennis serve, again, I will be anticipating what type of serve that is. So has it got some top spin on it? Is it a slice serve? Is it just fast? So what type of serve is it going to be? So I anticipate before the action happens. It's been shown that people like tennis players, like cricket batsmen who are facing fast bowlers, that you need to anticipate and actually start your movement before the ball is bowled or before the ball is hit in terms of the serve, to give you enough time to actually hit it. So anticipation is key. Using mental rehearsal is another one. So we can mentally rehearse in our head. Remember, mental rehearsal is a good technique that we can use for improving lots of factors in skill. So if I mentally rehearse the right cues and responding in the right time, I can improve my performance. The intensity of the stimulus, so I could make it brighter, I could give a warning signal, I could make it louder or bigger in terms of my practice that I'm doing, in order to make response time a little bit easier. And lastly, I can improve fitness. So if I improve my fitness, I might be able to improve the movement time section of my response time, which would obviously improve the whole thing as well.